Hi everyone, welcome back to Aviation Tips, and whoever is new, welcome to this channel. So this video is going to be very long because we're going to be talking about the nav log. And nav log is going to be from Milwaukee Chicago Executive Airport to Janesville. Um, so hope you guys are going to enjoy this video. This video is going to be long. I might divide it into parts, but if I can't, then just sorry for the whole lot of information. Alright, let's just go ahead and begin with this video. So for the startup, we need to have a couple of things before you guys start this process. You have to have a nav log sheet, which will exactly look like this. You can pull it from Google. It's just generic nav log. And then you need to have either SkyVector or ForeFlight. Well, I pull both of them because I'll grab true course from SkyVector, and ForeFlight I don't have to go to aviationweather.gov. I'll just pull all the information from ForeFlight. You need to have a calculator. You'll see some commercials about my calculator. Just ignore it, because it's free. Now I have a PDF of. I do have my POH in my PDF here. So you need to have your POH ready, and then I do have a E6B manual spark keys for free. You can download that one too. All these things that we need, hopefully is here. So let's start with the nav log, this sheet here. So I'll be jumping back and forth. Don't get confused. If you get confused, rewind and rewatch it. All right, let's go with the nav log. Alright, so Navlog, basically we're going to start from top and continue all the way to the bottom. Aircraft number, we'll just make it out 1, 2, 3, Sierra Papa, for example, and then route KPWK to KJVL. Notes, we'll go into the ForeFlight and you look at the route. And in notes, we'll talk about it in the ForeFlight. Let's go to ForeFlight. All right. So there we go. There's where I live here. Perfect. All right. So there's Milwaukee, and there's JVL, Janesville, Southern Wisconsin Regional Airport. So this is this is good for your 50 nautical mile cross country because it's a little bit more than 50 nautical mile, so it's perfect. The points that I've picked, it's just to make this video shorter. I already picked them. The first point is Lake Zurich. You can clearly see it, and then from there we just second point is Woodstock, and on and on. We do have the railroad crossing through these towns onward. Harvard, then you have Lincoln. Well, I think it's going to be our top of the descent, depends on what altitude we're choosing. Okay, so that's the route there. What do you need to do here for your note section? Just divide this whole route and then pick all the NOTAMs, TFRs, and frequencies that you need to pick and plug it in your notes. And then on the other section, same thing. You need to pick all the notes from parachute jumping areas that you have to be aware of and talk to approach about them and all the cool stuff. NOTAMs or any TFRs that you have to go around. All that stuff needs to be on your notes. So we're not going to go in depth about your notes. Continue moving forward. Go back to our so you've written all the notes here. That's perfect. We continue to this section here. This box says airport, so we'll just put in arrival KJVL. Looks like it's pretty big. All right, KJVL, traffic pattern altitude TPA. Now, usually 1,000 feet above ground, but we'll go ahead and take a look. If you're doubting yourself, you gotta go to AFD's chart supplement and pull it out and see. But I know it's 1,000 feet, so it's gonna be 1808. So I'm just gonna keep it at 2,000. So say 2,000 feet to simplify things and make this video a little bit shorter. In this box here, you need to draw the airport, um, draw the runways, all the runways, and draw your entry into traffic pattern. So, for example, you're drawing all those runways and whatever, and then you coming from southeast. So if you're coming to land runway 18 or something, you have to draw how you're gonna possibly enter pattern and land. In this case, it's left turn runway 18, left traffic runway 18, entering 45, left downwind. That's it. You could go to your ForeFlight or your anywhere you want to, but it looks like it's pretty much, I guess it's just favored what I was saying, runway 1615. But in case the runway is closed or something, you can just choose another runway and draw it again in this box here. Now coming back here, we'll start filling these boxes, with information of cruise information. So cruise altitude, all of these power, pressure, altitude, temperature needs to be pulled out from the POH. So I have to go in here and try to pull them out from POH here, section 5, performance sheets. So if I go to this table here, it looks like we, let's assume that we have calculated our weight and balance. Obviously, before we start our nav log, we have to make sure our weight and balance are calculated and we know our weight. For this scenario today, we'll have the maximum weight. So maximum weight, and we'll just choose the altitude of 6,000 feet just for the heck of it, so we don't waste time in this video. I hope you know the when you doing a VFR, when you planning a navlog, VFR navlog, you need to know that if you're going magnetically to the west, toward the west, you need to be even plus 500, or east, easterly headings, magnetic headings, odd plus 500. But for in this case, we're doing just even, so we don't have to deal with any interpolation between those 6,000 and 8,000. So we'll just choose 6,000 for the heck of it here, 6,000 feet. Now we need to choose power setting for this airplane. What power setting we're going to be cruising at. So we usually normally in Cessna 175 choose 75% brake horsepower. But in this video, again, I'm just going to keep shortening things out. I don't want to interpolate between anything. I just want to keep, shorten things. So I'm just going to pick 70%, 2,500 RPM, or 65, whatever the temperature column we're going to end up under. So let's go ahead and take a look for our cruise, what temperature we're going to be dealing with. So in this case, we kind of deal with all these non-tower airports around here, but I don't think we will have any of them broadcast doesn't have a METAR or anything. We'll just go ahead and pick up from either Rockford or Page, or we can pick up from Milwaukee. So whatever you want to pick up, whatever airport is closer around your en route, or you can go to aviationweather.gov and take a look what's the temperature you're going to be expecting. Or you can go to ForeFlight and just press temperatures, and you can see these temperatures are kind of -1, so just pick up -1. How about that? It's just surface temperatures though. But if you want to do cruise, so you have to kind of go, let's say Rockford, we're going to go winds and temperatures off 3,000, say 2 degrees, -2. So let's pick -2 degrees. We say we found -2 degrees. Now between standard and 20 below -2 degrees, so it's like almost 17. So let's pick 20 degrees below. So we'll just keep this simple. We'll pick 70% power and 2,500 RPM, and our true airspeed 115. 9.6 is our gallons per hour. If you look all these under these numbers above here, you will see these column here coming down like that. Now we're going to go ahead and write them down. Do we have any notes? No, we don't have any notes. So we'll just go ahead and write them down. So 70%, 115, 9.6. So just write them down in this column here. Cruise altitude, we'll choose 6,000 feet. Power, 70%. Pressure altitude, we'll deal with it in a second. Temperature was -2 degrees. True airspeed will be 115 and 115. What am I doing? 115, not 19. 115. Indicator airspeed you will see in your gauge. And gallons per hour, we'll do 9.6 as was showing. Manifold pressure we do not have for Cessna 172. 182 you might have manifold pressure. I think you do have for that one. High performance. RPM setting will set, it's going to be 2,500 RPM. Fuel on board, 53 gallons total will be for today's flight. So we don't have to worry about any fuel today. Obviously still we have to calculate pressure altitude. We come back here, as we know, we can go look at the METAR, and METAR, it says 3006 in here, 3006 at Rockford. So we'll just pick up for the heck of it. We don't have any other airports closer. We'll just pick up this Rockford here, 3006. Now, pressure altitude, we have to calculate the pressure altitude. We have to subtract from standard pressure always first. So 29.92 minus 3006, I believe. Yep, 3006. And that's going to give you either minus or plus number. And this is, if you do the decimals, for example, counting, you always count it, the opposite direction in this case. So thousands, hundreds, and tens. So decimals. So it's minus, that means 140 feet. So it's not much difference. We're going to go back and choose 6,000 feet. That's our pressure altitude. Now coming down to our next column here, it says checkpoint fixes. So it's going to be KPWK, our airport of departure. VORs, I will keep them blank in this case for now, because I'll show you how to use them. It's really, if you use VOR radials, when you cross your point, it's gonna be a lot easier for you to find your points. So for now, I'll just keep them blank. Of course, I'll just go to SkyVector, because SkyVector shows you true course. True course is when you plot, when you get your plotter and put it on your sectional, that's when you plot from one point to another. that shows you true course. So that true course of ours, and the reason I'm not doing in ForeFlight, because ForeFlight does not show me, or I cannot still figure out the true course. It does not show its magnetic course always in ForeFlight. There's my mouse. I was looking for it. So there's 305 degrees 59 nautical mile. So I'm going to go ahead and plug that in here. Course 305. Altitude. Now I have to plug in pressure, altitude. Let's go to ForeFlight. And let's go to Milwaukee. What is our pressure altitude? Pressure altitude would be, so let's get the non-standard pressure, 3009, subtracted from standard pressure. If you guys know how to do this in your mind, you good. 3009, because I always want to use calculator. I don't care for you guys in this video. Alright, so it's minus 17, so 170 feet. I know the field elevation is 640. Where is it? Field elevation is 640. So, airport information. There we go, 647. So 140. So let's say 500 feet is pressure altitude today. So let's go 500. So we're departing from 500 pressure altitude to. Now you need to know your top of climb. When do you want to stop your climb? For temporary or whatever. So let's take a look. Let's get these temperatures away. So for that, in order for that to look, we need to see what are we crossing, where exactly we're taking off, what runway. So I wonder why it does that. There you go. So I need to look at my winds. Winds are 17013, gusting 20. So we're going to be taking off runway 16 definitely. So we'll do a left turn probably. Tower's going to give us. Left turn end up bringing us under this shell here, 2,500 foot shell. Then we'll be under 3,000 foot shell. Then we'll be under 3,600 foot shell. And then we'll get off of this Bravo, clear off of this Bravo around here, so we can start climbing again. But we could either go climbing step by step, like climbing steps, or we could just do one altitude and maintain that till we get cleared off of the Bravo. But let's see, we will, so once we take off, let's just be realistic. Once we take off, we'll take off runway heading for up to probably a couple of miles out, so we can get to 500 feet AGL, right? It depends on pressure, so right around there. That means it's gonna be similar heading, but we have to make sure know where exactly we'll be turning and what are we going under. So we're going under this shell here. So that means we gotta stay at 2,000 feet. So we'll have to climb to 2,000 feet pressure altitude. So that means we have to go back and let's do this 2,000 feet. Okay. Now winds and direction, velocity, temperature, we'll pick it from the airport itself. We'll just go Milwaukee. We'll go 17013. This is gonna be okay, but sometimes you get a gust, you're not gonna have a headwind of constant headwind, so we'll get a gust. So let's just add half of the gust factor. So half of gust factor will be what, 13, 27, so make it 4. So let's make it 16 knots. 170 at 16, and temperature is 1 degrees. 170 at 16 and 1 degree Celsius there. Now, in order for us to find our true airspeed, we need to figure out our calibrate airspeed, and then we'll figure out true airspeed. What is calibrate airspeed? So let's start with the indicator airspeed. So you guys 100% supposed to know that Cessna 172 in the POH says best rate of climb is 74 knots. That's indicator airspeed, right? Now we need to figure out. So I'll usually climb 79 knots. So let's just go with the 79 knots. 79 knots, indicator airspeed. What is indicator airspeed? Indicator airspeed is the airspeed that shows on the indicator. Calibrated airspeed is the airspeed corrected for installation and instrument error. So that means we have to get our indicator airspeed and look at the calibrated airspeed. What is the difference? How much of a difference we are dealing with? So let's go to that table, since they provided us this table. So this one is let's see. Let's take a look. This one right here. This table is alternate static source, and this one is normal static source. We'll just use normal static source for today. If we look here, we are doing 79. The calibrated airspeed flaps up. It's going to be 77. So we'll just use 77 knots. Alright, 77 knots calibrated airspeed. So we'll just go ahead and plug that in, 77 knots there. Now, what is true airspeed? True airspeed is the airspeed corrected for non-standard temperature and pressure. Now, by saying that, we'll go ahead and pull non-standard temperature and pressure. Pressure altitude is 500 feet. Temperature is 1 degree. Let's go to E6B. And our calibrated airspeed is 77. So we're going to E6B, which is Sparky's E6B. So we know that this table, what we're going to work is this table only. So minus here, plus is that on the outer scale. Inner is your pressure altitude. So let's go. I cannot zoom in, so I'm sorry about this. That's the only thing I can do is just spin the wheel, and you guys, that's the only way you can see. So go +1 to 500 right there. So if you look at this, that's 500 feet, and there's 1 degrees. 1 degrees, 500 feet. Right there. So that means we got to look now on the inner scale right here. And not inner, because this is the hour scale here, but the second inner scale here, it says 75, 76, 77. And if you look out on the outer scale, it says 75 here, 76. So we'll have true airspeed of 76 knots. 76 knots. Now we need to fill out the true course. Where true course, we're going to pick it from here, and it's going to be 305, whatever we plot. Now, wind correction angle, we need to plug that into E6B wind side. So how we do that, we have to plug the wind velocity and direction, then plug the true course, and then plug the true airspeed. That's the order you're going to plug in to figure out your wind correction angle, and at the same time you'll figure out your ground speed. So let's do that. 170, 16, and 305. Wind side, I'm just going to reset this. I'm going to go to 100. Reset. Slide this card up to 100. There we go, it's our 100. Now we're gonna go, what are the winds? What were the winds again? 170 at 16. 170 at 16. So we'll spin this wheel here to 170 at 16 knots. 170 there under true index, and at 16 knots we'll just increase the orange line to 16 knots. There it is. There's 16 knots. Now we're going to go into the true course, which is 305. So we can spin the wheel again. 305, 305, perfect. And our true airspeed, it was 76. So let's go into slide that cart down to 76. And there we go. Now we have wind correction angle. This E6B gives us perfectly wind correction angle and ground speed right here. So if you can read it through this, it'd be cool. If you want to read it through here, you can cool. 9 degrees left means left 9 degrees, 86 knots. Let's go back to, so we got minus 9 degree because it says right here, left minus right plus. So we're going to be minus 9 degrees, and then 86 knots, I believe, was our ground speed. 86 knots, perfect. Now we continue. It's just we got this one, so you don't get confused. It's just because we did a couple of things at the same time, so you don't have to go back and forth and redo it to find your ground speed. Now we're going to do this table here, this column. So finding true heading. What is true heading? It's true course minus wind or plus wind correction angle. You get a true heading. So you're basically adjusting for true course, adjusting for a wind angle. That's your true heading. Now we're going to put a true heading of 305 minus 9. What is that going to be? 305 minus 9. Let me pull up sip my coffee for a second. All right. So 305 minus 9, that's going to give us, let's see, 296. So 296. Now we have true heading. True heading, and if you look at the east is minus, west is plus, and that's variation. So you have to look at your chart chart here. Not chart supplement, sectional chart. This line right here is 3 west. It says 330, but we'll keep it 3 west. We'll go in here and say plus 3. And now we're going to get magnetic heading. So what is magnetic heading? Obviously, it's true heading corrected for variation. And that's our magnetic heading. 299. And then deviation is basically, you do have a compass deviation card, and your airplane should be right next to your compass or below your compass, or wherever you keep it. It should be in the cockpit. Otherwise, the aircraft's not airworthy. Or in plus in the POH. So in this case, I will just use +1, but you have to go and grab it and make sure you plug your number there. So that's 299. I'll just make it 300, and that's going to be our compass heading. So what's compass heading? Corrected for all that stuff, junk. That's your compass heading. Now we need to figure out our distance, time, and gallon per hour. You know, that's the only time for your first leg that you're going to go into your table in the POH. So we're going to go into your POH here and go time, fuel time, and distance. Come on. All right. So, sorry guys, you have to bear with me. I'm drinking my coffee and talking to you guys and trying to stay awake here with you. All right. The time, fuel, and distance to climb at 25-50 pounds. So what exactly we have. Conditions: flaps up, full throttle, standard temperature. Now, if you don't have these things, you need to adjust for it. Like for example, we always have flaps up and full throttle when we take off in Cessna 172. Standard temperature, if it's not standard, we'll show you in the notes here below. Or if you're taking off above 3,000 feet MSL, you will have on the notes. We will go through them. So we are at 500 feet. So let's go into this table here. So we are going to be climbing from 500 feet MSL, pressure altitude, to, it depends, what we said. We said we're going to climb to 2,000 because, just because we need to be under the Bravo shell. So that's 2,000 feet MSL. So at 500 feet MSL, we need to kind of interpolate. We don't have choice for this. It's 0.5, 30 seconds there. And then the fuel going to be used. We'll take out fuel of 0.2 there, and then distance is 1. So we will climb to this here. So that's going to be 2.5, 2.5, 2.5 minutes. And then you have that the fuel will spend 1.0. Whoa. Yeah, 2.5. Fuel is going to be 0.6. Not 1.0, not that number. Not that number. So from 4, when it's going to be 3 nautical mile. So it's going to be 3 nautical mile and 0.6 gallons, 2.5 minutes to get to get to 2,000 feet. But we're not going to finalize that. It's just going to make it clear here. 2.5, 0.6, and 3 nautical mile. So now we need to read these notes. It says add 1.4 gallon of fuel for engine start, tax, and takeoff allowances. So we're going to go ahead and do that. 1.4 into fuel there. Now it says make sure to lean above 3,000 feet for maximum RPM. That's what I said. If you're taking off above 3,000 feet, you need to lean and make sure for maximum RPM. Otherwise, you're going to be too rich. Increase time, fuel, and distance. By the way, we're not taking off. As you know, we are doing 500 feet pressure altitude. Increase time, fuel, and distance by 10% for each 10 degrees above standard temperature. We're below standard temperature, so we're good. Distance shows are based on 0 winds. We do have some winds. Now, if you want to go really in depth for private pilot, you could, to figure out how much extra and stuff. There's a formula I can show you in a second, but it's not gonna make so much of a difference. For private pilot, I usually go with these final numbers here. But for those of you who you want to just go crazy on these numbers, we can just put in the formula. For example, your timing. You have 2.5. You need to multiply by what is your tailwind. So you're taking off. So you're gonna start turning toward your course. You will have 170 at 16 knots, right? So we can do 2.5 minutes times 16 knots, and that's divided by true airspeed of 70. How much? 76 knots, and that would equal to whatever you get. Now, whatever you get is a little bit tricky. You need to know if you have a tailwind or headwind. If this is tailwind, that's minus 16. you need to do what's going to happen to your time. Would the time increase or decrease to get to your point? Obviously it'll decrease, so you're going to subtract from this. And same thing with the fuel, but we're not going to do with the distance. So that's how you're going to do it. But for our video, I don't want to make it, you know, so long, and I don't want to make it so complicated for private pilot guys. Just ignore that for now, and go with those numbers that I have here. Cool. Let's continue on. So we have 2.5 minutes there. 1.4 plus 6 is 2 gallons there, and 3 nautical mile. 2.5, 3 nautical mile. What was the gallon? 2 gallons total, and then time was 2 gallons, time 2.5. Time 2.5. So 3 gallons, 2.5, and 3 nautical mile, 2.5, and 2. 2.5, 2, 3. Good. Sorry, guys. Just wanted to make sure we're 100% on it. Yes. So there we go. That's our first leg. What do you write here is your distance, total distance that we got from SkyVector, for example. If you look at the SkyVector, it's 59 nautical miles shows here. You can just plug that in that box and continue subtracting. 59 nautical mile minus 3. That's going to be what, whatever. You get 56 here, and then continue on. But I'm not going to do that, so you can do it. Now coming down to the next point here, this is, we said we're going to be it's going to be top of climb, right, for this first leg. So top of climb is going to be 3 nautical mile distance. So let's go into for flight, and we will be, let's just count it from here, just because we took off. And so wow, that's going to be pretty fast. High pressure altitude. That's your top of climb, 2,000 feet right there. So you're going to be at 2,000 feet right there at this point. So you need to cruise. Do you want to cruise at 2,000 feet, or you want to cruise? I would definitely cruise at 2,000 feet until this point right here, and then I'll climb to I'll climb to kind of 3,000 around there. So that's good. That's our first favorite. Now we're going to be Lake Zurich, 2,000 feet. Let's just, for sake of it, say Lake Zurich here. Lake Zurich. I hope I spelled it right. Lake Zurich. Yeah, Lake Zurich. So that's Lake Zurich there. Now we have same course, 305, and we'll be at 2,000 feet. The winds we'll just keep the same wind, 170 16, 1 degrees Celsius. Now true airspeed will change because we'll be kind of going fast at that point. We just climb to our 115, climb to our 2,000 feet, and we're 115 knots now cruise. 115 knots, and true course, same thing. Now we're gonna go ahead and take a look. We'll say just same thing, 90 minus 9, it will give us 296, and plus 3 variation, 299 plus 1, 300. Cool. So now that's gonna give us the ground speed will be different though. ground speed will be different because your true airspeed is a lot faster and you have tailwind. So that will differ from the first leg. So let's take a look. Actually, that would be that will actually would change a little because your true airspeed. So let's just go ahead and do it the right way. Let's figure out now the wind correction angle and the ground speed for 115 knots of true airspeed. So we're gonna have to go to, again, wind side of the E6B. So 17016, 305, 115. Let's go back here, 100 velocity, 170 at 16. Alright, so and then 305 true airspeed, and then grounds, 305 is true course, and then true airspeed of 115. And now we can see -6 wind correction angle and 126 ground speed. So -6, not much of a difference, but you know, 305 -6 and 126, I believe. There we go. 126 is your ground speed there. Okay, so 305 -6 is 290. 305 -6, 299, I believe. 299. And then plus variation will keep it the same, +3. That would be this. That would be same thing, I guess. Not much of a difference. We'll stay not far away from variation line. What else? So the 290. No, so now variation +3, 299. +3, that's gonna give us about 302, and then we'll just keep that deviation +1, so 303. So not much of a difference here. If we would have kept the previous numbers, we would be fine. Now 126. Now we are done with these boxes here. Looking at the distance, going from your top of climb to your Lake Zurich, we need to count that. So there's my top of climb. Where's my cursor? Every time it gets lost. There's my top of climb. We need to get all the way to Lake Zurich. I'm just going to put my 2 fingers and calculate 8.2 nautical mile. Hope you guys agree. And that's why I was saying it just shows magnetic. See? You guys see that? Magnetic heading 307. So it's 8.2. So let's go 8.2. We'll just fill this box here. 8.2 nautical mile. Now we do have the distance and ground speed. We need to figure out time. How can we do that? We'll just plug this in the E6B and figure out our time. Let's go ahead and 126, 8.2. Go to front side of the E6B. We're traveling 126 nautical mile per hour. 126 nautical mile per hour. There's a 60 rate under. 125, 26 nautical mile per hour. And we travel, I believe, 8.2 nautical mile. So if you look at the outer ring, 8.1, 8.2, outer ring, 8.1, 8.2, we look at the inner ring, that's going to give us time. So this is 3.5, 3.6, 3.7, 3.8, 3.9. So let's say 4.0, 4 minutes. 4 minutes, it's going to get us 4 minutes to get to 4.0 to get to our Lake Zurich. But how much fuel we can spend, we're going to discuss that in a second, which we have to see if I missed this here. 115. There we go. There we go. All right, so fuel, we have to look at our cruise fuel expenditure. So we're going to be spending 9.6 gallon per hour. And then we will be traveling 4 minutes. So 4 minutes at 9.6 gallon per hour. So let's go plug those in. So going again 9.6, 9.5, 9.6 gallon per hour. And we'll be traveling 4 minutes, and that's gonna give us 0.64 gallons. 0.64 gallons. You can see outer scale here, 0.64 gallons of fuel. 0.64 gallons. So that's what we're gonna be traveling. How much we're gonna spend fuel to travel to Lake Zurich. Okay. Now, from Lake Zurich, we need to plan what are we going to do. Are we climbing, or are we just going to stay at 2,000? So let's go ahead and figure that out in this flight. So there's our Lake Zurich right here. And there's our second checkpoint, which is Woodstock. Right on the left, there's a railroad crossing, beautifully set here. And on top of it, these are jet arrivals, so we have 6,000 feet is perfectly good for us, because we don't want to go higher than 6,000 feet. The way it looks, jets arrival are coming this way, and then they probably go that way. So from Lake Zurich, definitely need to climb though. We need to climb from Lake Zurich to at least 3,400 or so, or 3,000, or let's say 3,400, 3,000, or 3,300, whatever. So we have to climb. We can do that climb in here. And then we'll divide this into top of climb again in Woodstock. Alright, let's do that. And we have to figure out. So from Lake Zurich, we'll do this box is top of climb again. Top of climb. And from top, so the course will be same thing, 305. And now from pressure altitude of 2,000 feet, we'll climb to, let's say, 3,000. Let's just say keep it 3,000. Just keep it, for the sake of interpolation, we don't want to get going too crazy on this. So, from 2,000 to 3,000, look at the winds aloft. I don't think we'll be able to pick up winds aloft from 2,000 to 3,000. So let's just go ahead and pick up from 3,000 feet. In order for us to do that, we're still close to Milwaukee, so why don't we just pick Milwaukee's weather winds aloft in here, right there. So let's go winds aloft, 3,000. Temperature is going to go minus 4 degrees Celsius. ISA minus 13. We'll just go with the temperature minus 4. So 183 at 18. Minus 4, 183 at 18. 18. Minus 4, 183 at 18 knots. Now, you guys know that we'll be climbing at We know, everybody know that after 1,000 feet AGL, we have to climb, so we have some cooling going on. Excuse me. So I have to cool the engine. So we'll go ahead and climb at 90 knots indicated, 500 feet per minute. Okay, so keep that in mind. We'll climb. Let's write it in here. So you go 90 knots at 500 feet per minute. So passengers are comfortable, and that will be good for us. So 90 knots of indicated IAS, we have to go back to POH and figure that out if it's going to be what's going to be calibrated for in that case. Still, we have flaps up. We look at the 90 knots and it's going to give us 87. So we go back to this. We got our calibrated airspeed of 87. Now we got our calibrated airspeed. We are climbing from 2,000 to 3,000, right? So that's gonna give us about roughly 1,000 feet to go, and we have to divide that by 500. So that's gonna be two minutes, right? 2 minutes. It's gonna get us 2 minutes to climb 1,000 feet. In Cessna 172 at 90 knots, 500 feet per minute. We'll definitely have the full power in Cessna 172, and that's going to give us another thing, which is 15 gallon per hour. Anytime we push the throttle all the way full, we'll have the 15 gallon per hour rate of expenditure. You can see, look at your gauge, you will be spending 15 gallon per hour. So we have 87. Now we're going to have to figure out the true airspeed. We have to figure out our true airspeed. So calibrated airspeed is 87. We do have pressure altitude of 2,000 feet, which we'll keep at 2,000 feet because we don't like 100 and something feet less. We don't care so much. So 2,000 feet and minus 4 degrees Celsius, 87 calibrated. 2,000 feet. Still, we're going to go into this window to figure out our true airspeed. 2,000 feet will be 1 tick mark, 2 tick mark, and temperature's minus 4, so we have to go minus 4 right up there in between. So we're going to slide that into minus 4. That's 5. Right there. So right there, there's 2,000 feet. Pressure altitude, minus 4. And that's going to be that. And then 87 knots of calibrated airspeed. Inner circle, you have to look in 85, 86, 87. And then look outer scale 185, 86, 87 exact. So we'll be climbing at 87 knots of true airspeed. So that's that. 87 knots of true airspeed. Climbing. And now we'll put in our true course again, 305. We have to figure out our wind correction angle and the ground speed for this climb. So 183 at 18 minus 4, so we don't worry about minus 4. 183 at 18, 305, 87. So we'll have to come back. 3 at 18, go to wind side, go reset, go to 100. 183 at 18. 183, 1, 2, 3. Oops. 183 at 18 knots. And then our true airspeed is 87 knots. I'm sorry, true course is 305. Spin the wheel to 305. There it is. Oops. And 87 knots of true airspeed. Now we have 10 left. Wind correction angle, 95 knots. 10 left, 95 knots of ground speed. So that's going to be minus 10 and 95 knots. So we do have some tailwind still. So now we are, looks like we do have the 2 minutes. Remember, you guys, right up here, we are climbing 2 minutes. So we do have the timing. We got to plug the time 2 minutes there. And then we'll calculate the distance and fuel in a second. So coming back here, we went through the wind correction angle and ground speed. Now we're going to go ahead and plug everything in and continue on. So 305 minus 10, so that's going to be 295. And same variation, plus 3, 298. Plus 1, 299, which you could keep it 300, I guess. Plus 2, let's do plus 2 to make it simpler. 300 there. And then our distance, how can we figure our distance? We do have ground speed. We do have timing. We don't have our distance. What we can do, so just remember 95 in 2 minutes. We go to our E6B, we go to the front, reset. We do have 95 in 2, so 95 nautical mile per hour. And in 2 minutes, inner circle, come right up here. And that's going to give us about 3.1, 3.1.5, so 3.2 miles you're going to travel. 3.2. So 3.2 to your top of climb. How much fuel you're going to be spending during this 3.2 nautical mile? We have to plug in your 15 gallon per hour this time into 2 minutes. So let's go back to E6B. So go 15 gallons per hour, and then we have to plug in the 2 minutes, and that's going to give us 0.50 gallons of fuel. 0.50 gallons of fuel. 0.5. Perfect. So that's how you figure out your top of climb. So if you look at 3.2 distance-wise in ForeFlight, from where you climb, from Lake Zurich, 3.2, it's not that far out. You have good pressure going on. So we can just mark that by right up here. And then from there, you're going to, so currently you're going to be at 3,000 feet. So you'll be going toward Woodstock. Up to Woodstock at 3,000 feet. That's going to, rest of them is going to be 13 point either 1 or 13.0. So 13.0 to Woodstock. So now we will put in 13.0 distance there. So top of climb 3.2 and then 13.0 to Woodstock. The course will be the same, 3.5. So now you're cruising at 3,000 feet. through 3,000 feet, 183 at 18 minus 4 degrees Celsius. True airspeed is 115 knots. Everything else will change a little bit, so 305. So let's go back to the wind. 183 at 18, 305. So you got 183 at 18, 305. That's what we need, plus true airspeed 115. 183 and 18. Go to the wind side. We put reset here. Go back to 100. 183, 183. Oops. Alright, so 183 at 18. 183 at 18, and we're gonna spin it to 305 true course, and our true airspeed was 115. So we're gonna slide it up a little bit. 115. That's what we get is 8 left of wind correction angle and ground speed of 124. 8 and 124. So we go back here, minus 8, and we go to ground speed of 124. Still we have a tailwind going towards JVL for this. In this case, so that's good. So now we're gonna go ahead and let me clear this up right quick. Alright, so now it's 305. Continue with this box. 305 minus 8 is going to be 297. And then we'll keep that plus 3 variation. That's going to give us 300. Just keep it 0 this time. We'll keep the 300. Same course. Now we need to figure out our timing. How long it's going to get us to get to the Woodstock from top of climb. So we're gonna go 124 and 13 nautical miles. So go to the front page. We're gonna be traveling 124 knots per hour. 124 knots per hour, and we 13.0. 124, 13.0, where's our 13? Oops. 13.0, so it's right next to me, actually. And we're going to be traveling 6.1, 6.23, 6.3 minutes, 6 minutes, 3 seconds, something like that. 6 minutes, 3 seconds. Alright, that's the timing. Now we're going to be using, since we're cruising at 3,000, we'll just keep that 115 true airspeed. And the gallon per hour is going to be 9.6, so we'll use that. And we'll just keep it 6.0, 6 minutes there. And then we'll just go into 9.6 and 6 minutes. Let's see how much reset. So we'll spend 9.6 gallon per hour and 6 minutes of 6 minutes right here. That we're gonna spend about 0.96 gallons of fuel. 0.96 gallons of fuel. That's how much we're going to be spending to get to Woodstock. Alright, so now we're at Woodstock. We got to Woodstock. The course obviously is going to be the same because we never changed the course. Now you're after Woodstock, I would suggest you guys to start your climb, I guess, to 6,000 feet. But I don't know if you're going to reach 6,000 feet at Harvard or whatever. but we need to climb to 6,000 feet. So we're going to do the top of climb here. Top of climb could be Harvard. We'll just put DOC here. So 3,000 to 6,000. 3,000 to 6,000, we'll just pick winds or right in between. Excuse me. So from 3,000 to 6,000, we'll just pick one right in between. We'll call it at a 4,500 or 5,000. So let's go in here for flight. And I would usually go to aviationweather.gov and pick the winds aloft. But in this case, I see Rockford a little bit closer. So these airports are non-towered airports. I don't think they have weather. And then the Rockford is a little bit closer here, or DePage, whatever you can choose. We're not too far away from these airports, so we just pick. Let's pick Rockford and winds aloft. So let's say 6,000 feet. 6,000 feet. We get a 233 at 20 knots. Let's pick that. And the by the way, minus 2 degrees Celsius. Yeah, 20 minus 2 degrees Celsius. We'll be climbing at 87 again. We'll do the 87 true airspeed. We'll just stick with that. We don't have to worry with a couple of... If we have to plug in because the temperature is different now. So we'll just keep it at 87. It's fine. Let's say we found the true airspeed. But if you want to go in detail, just go the way I've done it here, or from late zero to top of climb. But we'll just stick with 87 at this point for the sake of the video here. And it should be very close to whatever we want to get. So now we will plug in our 305 course, and we need to plug in the winds and find our wind correction and ground speed. So let's go wind correction and ground speed. So we go 233 at 20. I'll go to wind side. Go to the 100 velocity. 322 at 20. Was that the correct one? 322. Let's see. 233 at 20. Sorry. 233 at 20 knots. 20 knots. And then our true airspeed. True course was coming 305 from 305. There it is. And our true airspeed was 87 knots. So let's go back to 87. As we can see, still 13 left and 79 knots of true airspeed. Now we have a little bit of a ground speed, headwind, crosswind, I guess. Slowing us down. So 13 and 79. So we go back here and we plug in minus 13 and we're going to plug in 79 knots. So we use this here for our first climb there. Not first climb, the second top of climb. Now we are climbing from same thing, 500 feet per minute. We're climbing from 3,000 to 6,000, right? So that's 3,000 feet difference. We are climbing at a rate of 500 feet per minute. So if I divide that by 500 feet, that's going to be 6. So that's going to be 6 minutes to climb. So we'll plug in our 6 minute here. 6 minutes. Now we need to figure out the distance. If we're climbing at 79 knots per hour in 6 minutes, how far we travel. 79 knots, 6 minutes. Let's go to the front of the E6B. So we go 79 knots. There's 79. I can't get it exact. It's 79. Oops. Can't believe it. This thing is just 79. Let's say 79 in 6 minutes. So let's go 6 minutes. It's 6 minutes. It's right up here. Cool. So 79 knots. 6 minutes. 6 minutes is just basically right here. I hope you guys don't get confused on this one. Because where's my cursor? I can't find it. Right here. Oops. There's your 6 minutes or 60 minutes or 600, whatever. So that's going to give me a distance of 7.5, 7.9 nautical mile. 7.9 nautical mile. Let's go ahead and take a look. So that's going to give us 7.9 nautical mile. From where are we going here? From Woodstock. So let's count that in. 7.9 nautical mile. Oops, almost there. So there it is, 7.9 nautical mile. And right up here, we are there. Pretty much not much of a distance left, 2 nautical mile, perfect. So, if we can figure this out, top of climb, we'll just say our top of climb is Woodstock too. Harvard or Daisy Airport right next to it. You can clearly see 2 nautical miles, not nothing, to be honest with you. At 6,000 feet, you can clearly see it. We're just going to clean this up and go back. We did say 2 nautical mile, correct? Yep, 2 nautical mile. Perfect. So now we do have the top of climb, 2 nautical mile left to our Harvard, right? Harvard City. That's 2 nautical mile. That's 7.9 there. But still, since we were there, that's why I've went ahead and gone through this and put the number here. So don't get confused. We continue moving forward, finding our fuel here. So we found our time. Now, fuel again, we were cruising. We're not cruising, so we're kind of. We climbed to top of climb. From Woodstock. We climbed from 3,000 to 6,000 at 500 feet per minute at 90 knots. In our fuel, I am pretty sure we have a full cram of power. Even if you lean a mixture, you will be spending about roughly 15 gallons per hour. So staying conservative, we'll do that. So in here, we will go ahead and spend 15 gallon per hour in 6 minutes. See how many gallons we'll be spending. We'll spend. Alright, so 15 gallons, 6 minutes. Let's go 15 gallon per hour. There's my rate. There's 15 gallon per hour. In 6 minutes, it's hour 60 again. So look, 1.5 gallons we're going to spend. 1.5 gallons of fuel here. 1.5 gallons of fuel we spend. Perfect. We now know. And then we did not even calculate what the heck was our true heading and stuff. So let's calculate that. So 305 minus 13, 292 plus 3 again. That's going to be 295. Let's say plus 0 here, 295. Not much of a difference, so 5 degrees. Alright, so now again, now from Harvard, from top of climb to Harvard, same course, this time at 6,000 feet. And we're gonna keep the winds 233 at 20 minus 2 degrees. Now our true airspeed is gonna be 115 knots, and true course 35. What we need to do is basically the same. We need to just make sure we are going through finding wind correction angle and ground speed. So let's go 233 at 20 knots, 305. Go to wind side, reset, 100 velocity, 233 at 20 knots, I believe. 233, 20 knots, and 305. So true course is 305. And true airspeed, going to slide it up to 115. And that's where our ground speed is 107, 10 left. Wind correction angle. So minus 10. And then what was 107 ground speed? 107. So there's going to be 295 plus 3, 298 plus 1, let's say 299. Let's make it 300. What do you think? And then we're gonna do the same thing. We're gonna find our time, then fuel. So 107 knots and 2 nautical mile. That's gonna be not much. From E6B, 107 knots per hour. Or 607 knots per hour. 2 nautical mile. Let's go inner outer scale. 2 nautical. It's gonna be 1 minute. So let's call it 1 minute. 1 minute. And then gallons 9.6 in 1 minute. So we're gonna go into 9.6 gallons per hour. And we're gonna be spending 1 minute. Inner circle right there. It's gonna be 0.16 gallons of fuel. 0.16 gallons of fuel to our Harvard. Now we're gonna be cruising. Same thing. We're gonna let's figure out one thing here. Now Harvard, we know our next point is Clinton, but let's say we're traveling at 6,000 feet, right? This is what are you gonna do when you get to airlines too? So you're at 6,000 feet, right? There's 3-2-1 rule. I hope you know 3-2-1. This thing is not writing. 3-2-1 rule. I hope you know 3-2-1 rule. For each 1,000 feet, you're gonna lose 3 miles. So we're at excuse me. So we're at 6,000 feet. Remember we said our TPA was 2,000 feet. Our TPA is 2,000 feet. So we need to go from 6,000 to 2,000 feet. How much we're going to lose? It's going to be 4,000 feet we need to lose. 4,000 multiplied by 3, that's going to be 12 nautical mile out. 12 nautical mile out. I hope you can see it. So we need to start our descent 12 nautical mile out. And as you guys can see, 12 nautical mile out, it's way up there. Right there, right close to Clinton, right? So right up here. Why is it not doing anything? Sometimes it's just acting weird. Right there. So that's our 12 nautical mile out. That's where we're going to start our descent. to our TPA. Usually they would give it about roughly +3 nautical mile on this 12 nautical mile here, because they want you to stay kind of get to your TPA a little bit further out. But it's up to you if you want to add 3 nautical. The reason I'm not going to add in this one, because I don't want you to go further out from Clinton, because you can see clearly Clinton in this case. But you could do it yourself, whatever you want to do. You can go descend further out 3 miles, add to it. Now 12 miles out +3 if you want. And then what is my rate of descent? So we have to discuss that one when we have to see our ground speed. In order for us to see our ground speed, we need to calculate everything. But distance, we know we have to descend 12 mile out. So where are we right now? We're Howard. We'll just write Clinton top of descent. So from Howard, we need to travel to Clinton. Same course, 6,000 feet to 2,000 feet pressure altitude. The winds will be, we can just choose, actually no, we're not descending. We're still going to maintain 6,000 feet from Howard to Clinton. From Clinton, we're going to start descending to top of descent. That's where, yeah. So our 6,000 feet there, and then we're going to maintain the same winds, -2. True airspeed is 115, 305, -10 plus, that's going to be 295, +3, 298. Let's keep it about +2, 300. There it is. Now we need to figure out our distance, which we saw. We kind of fixed, put it in here. Just need to figure it out. 2 fingers. It's 10.5 nautical mile. So let's go 10.5 nautical mile. 10.5, and our ground speed would be the same, 107. And now we have to go to our E6B, which is ground speed is 107, 10.5 nautical mile. 10.5 ground speed 107, so 105, 6, 7, and 10.5 nautical mile is right next to us. That's going to give us about 5.5. Where's my cursor? It gets always 5.5, 5.6, 5.7, 5.8, 5.9. 5.9 minutes. So let's say 6 minutes roughly. 6 minutes. Now we know our fuel is 9. We will be spending 9.6 gallon per hour in 6 minutes. 9.6 in 6 minutes. Let's say 9.5, 9.6 in 6 minutes, and that's gonna give me fuel 0.96 gallons. 0.96 gallons. Oops. Now that's my fuel to top of descent. Now top of descent, it's gonna be to your KJVL. That's where you're gonna go. Now you have to consider many things when we do the top of descent. We have to consider you entering TPA, spending fuel there, and then doing the pattern. Excuse me. Doing a pattern and landing on your runway. Let's say you've already chosen 150. So winds are 150. let's say you use runway 14. Actually, you will perfectly enter runway left downwind runway 14. So you'll be coming, let me clear this up. So you will be coming basically this way, entering left downwind and entering runway left down runway 14, and you land on 14. Actually, this thing from there to there, that's perfect because it will kind of increase your distance a little bit. So you have to kind of calculate that too. So let's say from here to here is 22 nautical mile now. So we don't have to in this video extend things so much, but we'll kind of consider spending a little bit more fuel than we're supposed to. I mean, I can calculate, but you're supposed to now know by now how to calculate a little bit extra fuel by looking at your time, look at your ground speed. But let's go and we will just add to whatever we find. So the course will be the same, 305. So it'll be from 6,000 feet to 2,000 feet. And the winds, we have to figure out the winds in here. We'll just get in between, whatever. So from 6,000, 3,000, let's interpolate, I guess. So you do have 225, and there's 185. So say 185, 180, 220. How many degrees? 40. So let's keep it 200, and then keep it 24 knots. Or 25 knots. 200 at 25. So, and then minus 3 degrees. 200, 25 knots minus 3. 200, 25 knots minus 3 degrees Celsius. Now, descending, for your descent, I usually descend same way. I usually descend 90 knots indicated. Let's say for the sake of not interpolating things and looking again at pressure, altitude, and temperature, looking for our true airspeed. Let's say our true airspeed 87 knots coming down, right? So we don't have to deal with that. 25 there. Now we gotta put in 305 here. And we have to go into the wind side of the E6B and figure the rest again. So 200, 25, 305, 87. 200, go back to 100, 200, at 25 knots. And 305 our true course in 87 knots of true airspeed. Now we have minus 16 left, 90 knots ground speed. Minus 16 and 90 knots of ground speed. Now we are descending from 6,000 feet, right? As you guys can see, 6,000 minus 2,000, that's going to give us about 4,000 descend that we have to descend to. And 4,000 will be descending at 500 feet per minute, right? So that's going to be what? 4 minutes, right? 4 minutes. I'm sorry, not 4 minutes. I was looking at something else. And that's going to be, I was looking at this here, 289 there, plus 3. So 4,000 divided by 500 is going to be 8 minutes, not 4 minutes. I was looking at something else, and I just mistake this. So 8 minutes, right? you have your 8 minutes coming down to 2,000 feet. But remember, you enter your TPA in 8 minutes. You have to add a couple of more minutes just because of entering TPA and then coming all the way around and landing. So 2 minutes, let's say 10 minutes total time, all the way touchdown. 10 minutes. So we'll just erase this 8 minutes. We'll put in 10 minutes extra. 2 minutes. Cool? And then let's go with the, so that's that. And then we have 289 plus 3, that's going to be 292. Plus, I don't know, 293. So now we need to figure out our, we set our distance from top of the sand to JVO. So we're going to go ahead and look again. Let's see, miles or something. Yeah, it's 12.2. So 12.2 miles there. But we'll keep it 12.2 just because we added a couple of more minutes. It's fine. So now we're going to go ahead and figure out our so let's see. So 10 minutes there. We need to figure out our distance. Actually, no. Let's see. It's the same thing, same concept. If you were descending at 90 knots, 10 minutes, let's plug it in. Let's see. Front. So you got 90 knots ground speed and 10 minutes of timing. That's going to give you 15 nautical mile. So that's going to be perfect because that gave us about extra 2 to 3 miles to do the perfect. Yep. So that's going to be 15 nautical. So we just plug in 15 nautical mile. And this was 293. 15. Now we need to figure out our fuel. Now it's up to you to figure out how much fuel. Are you being conservative? Or are you going to use this cruise fuel? Or are you going to choose 15? This is totally no. I would say that's too much. I would say, you know what? Instead of 9.6 or cruise fuel, you could do that. That's the best choice. Or you can just use simply either 10 gallon per hour to just stay conservative. So let's just do 10 gallons per hour. So you go in 10 gallons per hour in 10 minutes, right? So you 10 gallons per hour, and you're going 10 minutes, and that's going to give you about 1.68 1.6 roughly 1.66 gallons of fuel. 1.66 gallons of fuel there. Plus, the reason we added time, so we can add the, we added the distance there, and we added our fuel, 1.66 gallons. Plus, you have to consider taxiing back to, since we are not doing any run-up or anything, you have to consider adding some 0.7 to 0.8 gallons of fuel into this, so you get the taxi back to the ramp. So 1.66, let me get the calculator. 1.66 plus 0.8. Oh, that's going to be 2.4 or something. 1.66 plus 8.8. 2.46. So we'll just have the 2.46 of fuel 2.46 fuel all the way to touchdown and taxi to the gate. That's how we calculate the nav log. Plus, you could add some extra fuel if you want to. If you want to, for example, for like if they tell you, hey, make a wide downwind, or hey, just hold on, do not enter Cessna November 123 Sierra Papa, or they say Cessna, hold on, and you can't enter Delta, then you have to hold outside, or if they give you like a instruction to, hey, circle, make a 360 a couple of times, you can add those fuel, fuel for those kind of situation at the end, and then you come up with a total burn here. So what you do is add all these numbers, and I'm not gonna do that right now. You know how to do it. You add your timing and plug it in here, add your fuel, plug it in here, and add your distance and plug it in here. Distance should be almost similar, but a little bit more than what you have at 59 nautical mile, just because you're kind of doing the pattern, and plus 500 feet AGL going away from your airport of departure to get to your course. Alright, so and then you plug in your fuel here and you should be good to go. Plus, remember, daytime plus 30 minutes of fuel. Since you have the 53 gallon on board, you should be having plenty of fuel, but just for sake of calculations here. Now, remember I told you guys that I'm gonna talk to you about the VOR stuff. For example, you can put in frequency identifier here, you can put the frequency here, and then you can put the radial that you're going to be crossing under these points. Like, for example, top of climb. Let's take a look, see if we can come up with the one of those chords. Like, for example, let's go to ForeFlight. Come on, don't waste my time and everybody else's. Alrighty. Alright. There you go. So, for example, let's do the Lake Zurich. Lake Zurich is a lot simpler here. You see this VOR here? Let me draw it here. There's VOR. So you put in the frequency. There's a frequency box. If you have frequency there, that one is not. You see the dash line under that one. Report anything, any weather, or you cannot communicate or anything. So that frequency above it, 113.0, you can put it in there, put it in your nav 1, and then just twist the needle so it's from, and figure out, draw a line on your sectional, and whatever radial it goes through, like for example right here, it says 270 in here. This one is 260, so 1, 2, 3, 4, yeah, so 263. So this is 263 degrees radial from 263. I hope you guys can see it. So once you get closer to Lake Zurich around here, you will see that nav needle start moving, and you have dial 263 up above your nav, and there's your dots. You have dots on the left, on the right. You will see needle. Once it's centered, the needle is moving and it's centered, you're going to be right up top of your Lake Zurich right here. That's the easiest way. And then you can do the same thing to this one. You can draw the line here. Oops. Draw the line to this Woodstock here, and then you can change it, make it fun, make it more fun. So where else can we pick up? Do we have any other? Rockford, for example. Rockford VOR. You can pick Rockford VOR here. This should be somewhere at the field here. Rockford VOR. You can pick Rockford VOR or Janesville, and then you can just draw a line from Rockford. This one is not a VOR. I'm sorry. This is DME. Yeah. So let's clear this one up. Like for example, Janesville. There's Janesville. That's DME too. There's Janesville frequency. There's Janesville frequency, or any VOR that's in between. Or you can get a DuPage, for example, to cross these lines, and then do the same thing. Put it on your nav and see if once it crosses, you're right on top of your point. That's how you. I hope you understood what I'm trying to put out here. So I hope you now you're comfortable with doing the nav log, and just go with all the details that you can, and try to practice. I don't think I have anything else left to say, other than hope you enjoyed the video, and hope it's not boring. Hope for those of you who's really who has passion about aviation, would never get bored watching these videos, learning things, and spending some time. And for those of you who just here to grab your answer and quickly plug it in and forget about it, I'm sorry to say, but this is a pretty long video for you. And yeah, hope you guys enjoyed it. Take care, blue skies, and I wish you tailwinds. Spread the word to your other fellows, whoever wants these informations, and stay safe and stay proficient. Bye.